Welcome, let's discuss on differentiation and integration, and we want to stress majorly on the issue of kinematics. So kinematics normally just application part of the two, which deals with the motion of a particle at a given function. So we normally have terms like momentarily at rest. So momentarily at rest simply means that when the particle is not moving, and if it's not moving, then its velocity is zero. You also have maybe to find the maximum or minimum. So you normally differentiate the required function if it's the maximum or minimum velocity. So differentiate velocity with respect to time, then equate it to zero. Get the two times, then the maximum time will be the higher t, then the minimum time will be for the smaller t. So replacing the function as we shall see during the example part of it. You also have during. It can be during the third, maybe during the third second or time. During the third second, that means from moving from 2 to 3. So find for the 3, then subtracting for the 2, as we shall also see from the first example. Let us start with the example. The displacement, the distance covered by a particle through a point O is given by the equation S is equals to 2t cubed minus 5t plus 4t plus 2. Find the distance covered when t is equals to 2. Remember, S is the distance. So therefore, when t is equals to 2, you simply substitute whether there is t with 2. That means S is now becoming, S is equals to, that is part A, S is equals to 2 in brackets 2 cubed minus 5 in bracket 2 squared plus 4 into bracket 2, then plus 2. Where there is t less 2, use your calculator. So using your calculator, you end up with 6. And it is meters. Then the second part, or part B of the question, the velocity of the particle when t is equals to 3 seconds. Remember, we normally have a summary formula that from S you go to velocity, then you go to acceleration. If you have S, you go to V. So when you're moving down here, you are differentiating, or the opposite up here, you are integrating. That's normally the formula. So we are moving from S to V, therefore we are differentiating this one once. That means velocity will be given as the derivative of S with respect to t. And because you are differentiating this function, it becomes 3 times 2, then less 1, that is 6t squared minus 10t, then plus 4. Remember, in differentiation, you multiply the coefficient by the power here, then you less the power by 1. The same applies to the others. So that this is the function, but we have said that at t is equals to 3. So that is v3. We now substitute where there is t with 3. It becomes 6 in bracket 3 squared minus 10 in bracket 3, then plus 4. And again from the calculator, this is now 9 times 6, then minus 13, minus 30 plus, leaves you the 28 meters per second. Then the part C is the value of t when the particle is momentarily at rest. The value of t, part C, momentarily at rest means that v is equals to 0. Remember, the function for velocity already found it here. Therefore, just say that 6t squared minus 10t plus 4 is equals to 0. It's a quadratic equation. When using the quadratic formula, gives us t is equals to negative b plus or minus the square root of the square of b squared, then minus 4ac, the whole of it divided by 2a. Remember, our b is negative 10, so negative 10 leaves us with 10 plus or minus. What is in bracket here? It is b squared, so negative 10 squared plus minus, minus 4 times a here is 6, then times c here is 4, then the whole of it is divided by 2 times a. Our a here is 6. That gives us 10 plus or minus the square root of 2 from the, what is inside here, which is the square root of 5, which is 2. So divided by 12, 2 times 6. Choosing for addition, t1 is equals to 10 plus 2 over 12. That is 12 over 12, which is the same as 1. Choosing for subtraction, that is t2 is equals to 10 minus 2 over 12. That is 8 over 12, which is the same as 4 goes here, 2 over 3 seconds. Therefore, at momentarily at rest, t is equals to 1 or t is equals to 2 over 3. Then the maximum acceleration of the particle. So you have the function for velocity here. To move from v to a, you differentiate once to get velocity. So therefore differentiate to get acceleration. Therefore differentiating this one gives us 12t minus 10. If you differentiate this one, is 12t then minus 10 for acceleration. Then they want the maximum acceleration of the particle. Maximum acceleration, you also differentiate this one, then find the value of t if it will be there. So differentiating this one leaves you with 12 minus 0. So 12 will now be the value that you'll be left with. Remember, for a case whereby a is given as 2t squared minus 4t, they want you to find the velocity function. Then you know that from SVA, so when you have acceleration, velocity, you're integrating once. When you integrate, that one means velocity is the integral of 2t squared minus 4t with respect to t. That gives us 1 over 2 over 3t cubed minus 4 over 2t squared, then plus c, because it's an open integral. That means the final is 3 over 2t cubed minus 2t squared plus c. But if the initial velocity was something like 2 meters per second, that means that v0 is the same as 2 meters per second. Remember, this constant is normally the original addition when it was at 0. Therefore, to get this c, you now say that where there is t, you substitute 0, so that you have that where there is t is equals to 0 to give us this constant. That means v0, which is equals to 2 meters per second, is the same as 2 over 3 in bracket 0 cubed minus 2 in bracket 0 squared plus c. This 0, 0, that means that c is equals to 2 meters per second. So that now the function for velocity vt becomes, where there is c, you now replace with this constant, that is 2 over 3t cubed minus 2t squared, then plus. Instead of writing plus c, you now write plus 2 as the right function for velocity.